Chapter 6, Section 4, number 45. And here we have a problem where we're being asked to take the derivative with respect to x of this function that is defined using a definite integral. We can observe that the lower limit of integration is a constant, 6.3, and the upper limit of integration is a function of x, x squared. The integrand is natural log of cosine of t. So how do we find the derivative of such a function that is defined using a definite integral? It is an easy problem to do if you remember something that we've learned before, the second fundamental theorem of calculus. If you have an integrand that is continuous on an open interval containing a, in our problem a would be 6.3, then for every x in the interval, the derivative of the function with respect to x would be the integrand, but the t in the integrand would be replaced with the upper limit of integration. The only thing that we have to be careful about for number 45 is that our upper limit of integration is not just x, but it is a function of x. So the function that we have for number 45 is a composition of two functions where the inside function is x squared. So to find the correct derivative for number 45, not only do you have to use the second fundamental theorem of calculus, but you also have to use the chain rule and multiply by the derivative of the inside function. We'll get to number 45 in a moment, but I want to show you a straightforward application of the second fundamental theorem of calculus, and I'm going to modify number 45 so that it becomes an easier problem, so that you first understand a straightforward application of the second fundamental theorem of calculus, and then we can look at number 45 where you have to use the second fundamental theorem of calculus in conjunction with the chain rule. Suppose we have this problem, 45b. The difference between 45b and number 45 is that in number 45b, the upper limit of integration is just x and not x squared. So you can do number 45b just by applying the second fundamental theorem of calculus, and all you would have to do is look at the integrand, this is our integrand, and replace the t in the integrand with our upper limit of integration, and we would have our answer. So our answer for 45b would be natural log of cosine of x. And that's it for 45b. So what about 45? What's the difference between 45 and 45b? In 45, as I said earlier, we have x squared for our upper limit of integration. So we have a composition of two functions where the inside function is x squared. So to find the derivative for 45, not only do you have to use the second fundamental theorem of calculus, but you also have to use the chain rule. So let's take a look at that. So you can see that we begin by applying the second fundamental theorem of calculus. We are going to look at our integrand, and we're going to replace the t in the integrand with whatever our upper limit of integration is. In 45, it is x squared. So we replace the t in the integrand with x squared, and then we have to follow through with the chain rule. We multiply now by the derivative with respect to x of the inside function x squared, which is, of course, 2x. So we have 2x times the natural log of cosine of x squared.